All right, take out page 35. Let me explain the concept behind this. Okay, show it to screen now. Let me explain what's going on here. So I showed you the sound effect, but let's try to look into the physics behind it, okay? Because we need to understand the physics behind what's going on here. So what's actually happening here is we need to start from scratch again. Last class I just showed you what the sound sounds like. Let's see what's happening here. So you have this vehicle here, which is equipped with a loudspeaker that produces a sound, okay, and it's placed on the top of this vehicle. So you have this thing that produces sound and it's placed on the top like that, okay, and so sound is going to be produced from this particular vehicle, and the sound will travel in all directions. Okay, so sound will travel in all direction. Let me try to give you a picture of what that will look like. So this will be how the sound is moving everywhere. The intensity of the color represents the loudness of the sound. Okay, so যত দূরে যাচ্ছে, the sound is dying out. Does that make sense? What's happening here? So if you were an observer and you were standing right in front of this vehicle here, so this is the observer. Right, and this is our source. So you come out to that source. So that's our source. So our syllabus deals with the source moving, not the observer. The math is very different the other way around. So I'm ready for that the observer is standing there and the source is in the front, right? Now when your source is stationary and your observer is also stationary, what happens? So what happens is what's happening right now. You're listening to what I'm saying as it is, because the sound is traveling to me, right? Or from me straight to you. There's no deviation of the sound. But it turns out if the source is moving towards or away from the observer, things start to happen. Okay? And this diagram doesn't really help so much inquiry. So the observer is still here. That's the observer is. And sound coming from this vehicle. It just one, right? So আমার sound থেকে কি বলবো, draw the sound in terms of waves, not the one I've drawn above. Okay, so আমরা তিনটা scenario there, three things that can happen. একটা হচ্ছে the sound is the vehicle is moving to the right, so as a direction of the vehicle movement, and it continues to move to the right. We need to see how does the sound change as this happens, and sound can change over a bit. So if you have your source here at the top of the vehicle, how does the sound waves look like? So it turns out the sound waves look something like this. Normally sound waves এরকম দেখতে হবে, মানে if the thing was stationary, the sound waves would have looked like this. What are these lines called? You remember, or do you know? These lines that I've drawn of the wave, right? They have a name. Wavefront, very good. So wavefront is basically all the points on this wave, right? They are identical in their behavior. So it's called a wavefront. And we have these sound waves that are being released. Eta hoy when the trolley is what? Moving or stationary? Stationary. So when it's stationary, the sound is coming out as normal. But here's the interesting part. As the trolley starts to move forward and it simultaneously starts to produce sound. I will repeat, the trolley is moving forwards and it's trying to produce sound at the same time. What happens is by the time the wave tries to go forwards, who catches up with the wave? The trolley. Do you understand what I'm trying to say? Like, let's say if you throw a ball and your car accelerates towards the ball, wouldn't the ball get closer to you, right? And let's say if you throw the ball the other way and the car accelerates, wouldn't the gap get bigger? Do you understand what I'm trying to say? Because if the car and the ball were moving at the same speed and you threw a ball, right? In theory, they should maintain the same gap, but the ball doesn't maintain the same gap because of what? Air resistance and gravity and water, it becomes a projectile. But if the ball and the car were at the same speed, wouldn't you maintain the same gap? Do you understand what I'm trying to say? But here's the thing. You're trying to throw the ball and move towards the ball at the same time. When the ball gets, you're also going that way, right? What happens is the gap narrows on this side. But at the same time, if you throw the ball the other way and the trolley moves out, wouldn't the gap get stretched out? So what's the consequence of this? By the way, it's on the syllabus at 9. Like, why does this happen? Okay, our syllabus deals with what happens. So you know what happens here is that this starts to get skewed. Skewed মানে হচ্ছে একটা সাইডে narrow হয়ে যায় আর আরেকটা সাইডে হচ্ছে wider হয়ে যায়. So the sound will now appear like that. বুঝছো জিনিসটা? What's happening? So wake হচ্ছে when a speedboat goes through water, পিছে একটা white color water মতন spread out হয়ে যায়, that's called a wake. It is similar একটা shape. It's just done with sound waves here, right? So this is what actually looks like. So whenever you have a sound being produced by something, this is the diagram, okay? এরকম দেখতে হয়. Now, can you tell me, compared to the original sound, right? The front part that you see here, what is different about the front part compared to the wave I've drawn earlier? মানে এই যে front part দেখতেছো না, এই front part কি same spacing as before? No, right? What is the spacing? Shorter, right? And if the spacing is shorter, wavelength is smaller, but the sound speed is still the same. So when you wavelength shorter হয়, speed same থাকে, right? What does that imply about frequency? Higher frequency, right? So the front part here represents high frequency. This thing that you see here is a location where the sound has high frequency, or right term would be higher frequency when compared to before, right? And pichetta, the part at the back, right? Isn't that now spread out like that, right? So if the part is spread out, what does that imply about its frequency? When compared to before, a frequency the key hobe, yeah, lower frequency, right? Lower frequency. So the problem is, sound যখন release করা হয়, the sound has been released as normal. If you were on the car, right, or in the car, you'd hear the sound normally. But when the sound is spread out, when it's made to move outwards, right, it gets deformed and becomes like that. And if a sound becomes like that, and if this trolley, the one that we have here, তোমাদের দিকে যদি move করে, let's say this trolley is moving towards you, right? Can you tell me which part of the sound do you hear first? The high frequency or the low frequency? When if it's coming towards you, right, which one comes towards you first? High frequency. So whenever, and this is the most important part of this topic, whenever you have a source moving towards you, sound becomes what frequency? Higher frequency, okay? And similarly, that source, as it moves and goes past you, what happens to the sound? Which part do you listen to? Lower frequency. And this variation of the sound that is heard, right, is known as Doppler effect. Doppler effect is the change in the apparent wavelength and frequency of a sound due to the movement relative to the observer. It sounds complicated, it's very basic, okay? It's basically saying you that the sound will sound different, right? If an observer is observing a source moved by, and the sound that you observe is different, not the source actually, okay? So the people in the car, I mean, I think I showed the video with the Formula One car. The people in the car actually listen to the sound as normal, right? But people who are outside hear a different sound. So that's very important, okay? So does it actually change the sound? Does it actually change the frequency? No, because we know that there's only one way you can change frequency. What is it? In physics, when it comes to waves, right? What's the one official way of changing frequency? Changing the source. The source is what controls the frequency, okay? If your medium changes, does the frequency change? No, what changes? Speed, okay? So source is what makes the frequency, okay? However, here there is an after effect. কারণ এখানে কিন্তু সাউন্ডটা normally produce হচ্ছে, don't get that wrong, okay? But the sound that's heard is different, and the sound that's heard that's different is due to what effect? Doppler effect, okay? So Doppler effect is this thing. It is used in so many different places, and it's unfortunate তোমাদেরকে শেখানো হয় না, or from your point of view, it's fortunate, okay? কারণ তোমাদের just একটা ম্যাথ দিবে আর কিছু দিবে না, right? So এটা কোথায় কোথায় ইউজ করা হয়? This is used in, কেউ কি জানো কোথায় sound variation use করা হয় to detect things? Submarine sonar use kora hai. Sonar to different. Sonar to use kora for depth. Acha, I'm boli. I know since probably heard for the first time, you didn't know where it's used. Top five places where it's used. Number one হচ্ছে is used in radar. Planer je radar থাকে না করে ওই ওয়েভটা is like international, like a standard wave. Wave ta plane বাড়ি খেয়ে, what does the wave do? Come back. Now the thing is, imagine the plane is moving towards you and you send a wave, and the wave hits the plane and then comes back. Wouldn't the plane push the wave out? Wave to আসতেছে, okay, একটু ধাক্কা দিয়ে পাঠিয়ে দিবে না, because it has energy moving forward. That wave that comes back has what frequency? Higher frequency. And imagine there's a plane going away, you send the wave, or reach korte korte দূরে সরে গেছে. So what does it become on the way out? Stretched. So radar যখন দেখে একটা plane, they can figure out everything about the plane. They can figure out what speed it's going at, what altitude, what distance, what direction সবকিছু, just by this Doppler effect, okay? Speed কেমনে বের করা যায় is part of our syllabus. There's a formula where you can see how the wavelength changed, and that tells you how fast the object is moving. That's number one. Number two, use করা হয়, of course not by us, but it's the number one way of hunting by bats. Bats hunt করে যখন, I mean, imagine bats are কিন্তু blind. And if you close your eyes, what you see is what a bat sees with their eyes open, okay? So they're basically blind. But can you catch a fly? Most likely not, right? But bats, so they do it for fun, if you could say. How do they figure out where flies are? Because they're blind, right? Or কি করে? So they're basically screeching all the time. সারাক্ষণ চিল্লা যেতে থাকে. And what are they screeching? Ultrasound. That's why you can't hear it. So they're basically sending waves everywhere, right? And when the waves bounce off something, it comes to their ears. They have very big ears, right? ওই earটা ওই soundটা pick up করে, right? Their brain can calculate where the fly is, which way it's moving, what speed it's moving at. So it's very easy for them to capture. Same with dolphins as well. And some of the fishes, right? So you can take the Umbra inspired. The idea of using this in communication actually came from animals out there. আর একটা কথা ইউজ করা হয়, এটা ইউজ করা হয় Doppler ultrasonography. It's something they do for the heart. So heart যখন beat করে, blood যে veins they pass করে, ওটা speed কেমনে measure করা হয়. So back in the day, it was intrusive. They used to put something into your veins, like a machine, and as the blood flowed through the veins, right, it could measure the speed. Obviously very complicated. So what they just do ultrasonography. They send ultrasounds into your veins. If the blood is coming towards you, then a key frequency back করবে, higher frequency. If the blood is going away from you, key frequency আসবে, lower frequency, and you can actually find the rate using that Doppler shift. So yeah, Doppler effect is used in plenty of places. তোমাদের syllabus is just with a car and sound and a horn. That's it, okay? So it's just to demonstrate the effect of it. Are you with me so far? So yeah, this is your Doppler effect. So again, as an object is moving away from you, it gives you a lower frequency, and if it's moving away from you, towards you, it gives you a higher frequency. So before I give the notes on this thing, can you tell me what is actually the one that changes, the frequency or the wavelength? Okay, so এই প্রবলেমটা again fell for the trap. Wavelength is always a what variable? Dependent variable. Wavelength কে change করা যায় না, কি change হয়? Either speed or what? Frequency. In this case, it's the frequency. Okay, আমরা frequency যেহেতু draw করতে পারি না, what do I explain this through? Wavelength. What is actually changing? Frequency. Okay, so your definition as was Doppler effect. It's a change in what? Frequency, okay, of a source as heard by an observer relative to the motion of the source, right? So don't say wavelength, okay, it's the frequency. Yes, they will give you MCQs, but MCQ the wavelength থেকে change করে on the frequency version to select করতে হবে, okay? So yeah, there you go. That's Doppler effect. Something else just before I wrap this up. The faster your object goes, what the effect of the Doppler effect, more or less, higher the effect, right? So if a car goes by you, like very slowly, you wouldn't feel Doppler effect. But if something goes past you very fast, right, Doppler effect becomes more prominent. For example, Formula One cars, they go very fast. That's why even a normal car, it'll do the Doppler effect as well. Okay, so the point I'm trying to make here is the intensity of your Doppler effect depends on what, how fast you're going. Right. Right when it's right in front of you for a brief moment, it'll be normal sound. Yeah, so as this is the source, right? As the source just passes in front of you, you'll hear the original sound, but as it goes by, it'll be back to the high or low frequency because it's at the tail end. So yeah, you don't really get the original sound. Briefly sleep out, momentarily. Okay, so I'll give notes on this, but one question I think we can answer. It's used by bats, yes. It's used in GPS. I'm not aware of GPS use for it. It's used by self-driving cars, yes. Is Doppler effect used for the fetal ultrasonography? No, it's only for the heart. How do you know it's low or high in comparison? It's either one of them, right? Hey, it's either high or low, right? But how do you know? How do you know if it's a high frequency or a low frequency? Right, but how do you know it's high frequency? Yes, but how do you know? Sorry? So loudness is something different, right? So loudness is amplitude. Pitch, right? So how do you find pitch? I mean, it can be your ears that figure it out, right? But how do you actually find it? Yeah, cathode oscilloscope. We spent a whole class on this thing. It was like a mic and the sound came through and produced a graph and then you figured it out, right? So yeah, that's how you do it. Can you explain dependent independent variable? Yeah, so V equals to F lambda mode. Just remember V and F are independent and lambda is always dependent. Okay, so that's how it works. Does the loudness change as the car goes by? Yes, of course. Frequency change hoy or key change your loudness, because as something comes close to you, obviously will get louder, intensity very much, right? That's what's deceiving. Whenever I ask students what's happening, they say it gets louder and quieter. That's part of it, but what's actually happening? Frequency is also changing. Okay, so it's like a mixed effect. Is that why we only hear car sound when it's just passed, but keep hearing the sound even after we've passed it? Like if the car's approaching you, don't hear the sound, but it is going. Oh no, that's a little different. If a car, you don't hear a car and it passes by you and then you hear it and then you don't hear it, that's because the car is not what? Loud. Manor engine sound auto beshi na, so khali tomar kache asle shunte paro. There's nothing to do with Doppler effect. Yeah, so by the way, this is one of your question. এখানে যে soundটা শুনবে, the person hearing the sound here, right? What sound? Low frequency, right? But what about the person on the front? What will that person be hearing? High frequency. It's সামনে পিছের উপর depend করে, not where the person is standing actually. That means frequency also change with amplitude. Frequency change with amplitude না এখানে দুইটা জিনিস individually হচ্ছে. So amplitudeটা হচ্ছে বেড়ে যাচ্ছে তারপর কমে যাচ্ছে, আর ফ্রিকোয়েন্সিটা হচ্ছে বেশি থেকে কমে যাচ্ছে। সো এই দুইটাকে তুমি যদি মার্জ করে একসাথে যেটা আউটকাম আসবে, দ্যাটস ইউর অ্যান্সার। ইউ আন্ডারস্ট্যান্ড হোয়াট আই এম ট্রাইং টু সে? সো উপরেরটা কিসের ভেরিয়েশন শো করা হচ্ছে? লাউডনেস এটা, আর নিচেরটা কিসের ভেরিয়েশন শো করতেছে? Frequency, right? Now, if you merge these two waves together, then obviously it was an I. But or did you merge for then the outcome would be your what you hear. Okay, with that correct process, not part of our A2 they will learn about it. Right, so that's it. Any further question? This is the end of the first part. Equation and we'll be done. Please explain why it depends on the person standing in front of the car. It depends on the observer. Mane ei pura effect into I think exclusive for the observer. The source has nothing to do here. Remember redshift from astrophysics, right? Redshift ki chilo? That when galaxies moved away from us, what did they appear? Red. Are the people in those galaxies seen red everywhere? No, right? What are they seeing? Normal, right? It's just us that we see red. They are observed from some other part of the universe, right? They're seeing what here? Red. But we just see normal, right? So it's nothing with us. It's actually how the light shifts as it travels to the observer. With maskana data, that's what's causing the change. Okay. Right. So let's go through it. Do you have one? Oh, I used to follow a long time back. Fernando Alonso. All right, so this is all you need to know. What if the person stands in the middle where the car zooms around in a circle? Huh, interesting question. It O-level edit low. You're at the center. The question is a person has like a string, a stringer index attached for a loudspeaker that's playing a sound, and you're spinning that on top of your head, right? How does the sound vary? If you think about that, same. Right, distance is same all around. So how the sound change? Yes, very good. It's same. Acha, kintu, you're doing that, right? And I'm standing here. Will it sound same to me? Loud. Anything else? Yeah, I mean, you spin could say, right? Would you guys hear the sound same? Loudness, chara. I'm talking about the frequency of the sound. Will you hear it same or different? Lower frequency. Hold up. Yes, exactly. You hear high and low because as I spin it, doesn't it move towards you? High and then normal and then what? Low. Okay, so it keeps varying as it spins around. Okay, so I'll continue now very quickly. I want to wrap up this topic. Again, let's see if you can start the next one. Why does the wavelength decrease when moving towards? Shouldn't the wavefront be constant? Now that's the thing, that if your object is moving and producing the sound simultaneously, the waves are released, right? So one wave is going this way, but the car is moving forwards. It pushes the other wave forwards, and then it's still moving forwards. It pushes the other one forwards. So what happens is these things start to stack up on the front. So the frequency increases, but it's after being released. So the wavefronts are still there. If you see my diagram here, the waves are still following a perfect circle. But it's just that on the front, they're getting pushed together, and on the back, they're getting stretched out as a consequence. You mostly get these kind of explanation, but math. They give you a lot of math-based questions. Are you done? Okay, so one more time. So you're very stationary. By the way, ours deals with stationary observers only. It is possible for your observer to be moving as well along with the source. What you know, there's a chapter in math called relative velocity, which I really don't have anymore. No. I was such a long time ago, I don't remember. But point and that's I think a little complicated for math or physics. I don't know, they don't have that. So we only have observer staying stationary and your source is moving. So those are together, which means that my frequency increases. As it goes away, you can see that the waves are moving further apart, which means frequency decreases. Okay, and that's how the sound changes for you, not from the car. Car is still producing the same sound. The frequency will be changing more and more, like whatever the change is. So if it was increasing, it will increase more. If it's decreasing, it will decrease even further. Right. Can you go to page 37? Page 37. It's a new topic, so you won't find much questions in the past paper. I'll just let you know. Okay, screen it too. So let me show you the Doppler relationship. Basically, it's the Doppler equation. So এটা হচ্ছে the frequency that is observed is equal to, it's a formula that you need to know, okay? And as far as I remember, it's provided in your question paper, maybe, okay? But don't rely on that. আমি তাও বলি f equals to f naught. F naught is your original source frequency into bracket A. V is the speed of the wave divided by v plus minus speed of your source. So let me explain what these mean, okay? So obviously, এটা হচ্ছে the observed frequency. So observed frequency মানে কি? The one you hear, okay? So this is the observed frequency. This one is your source frequency. Source frequency মানে কি? The sound that's been generated by the source, okay? So source frequency. Now, the problem that students have is one, with which V is what, so it's careful factor of it. And the second problem is that they don't know when to use plus and minus. So I'm going to teach you a technique here, how to figure out plus and minus, okay? So তার আগে এটা হচ্ছে তোমার wave speed. Wave speed মানে হচ্ছে তোমার sound যদি use করা হয়, what's the speed of sound in air? 330 meter per second, right? So they use kora hobe. So this is the wave speed. Same with your wave speeds. This one is your source speed. Source speed mane hocche je the car, how fast is the car moving, okay? So the source speed. And a plus minus টা একটু বুঝাই কেমনে করতে হয়. So yeah, tell me something. I'll teach you a way of remembering, okay? If your object is moving towards you, right? Would you expect your frequency to be higher or lower? Higher, right? তার মানে আমার যদি ফ্রিকোয়েন্সিটা হায়ার হয়, can you tell me এখানে আমি কি প্লাস করব না মাইনাস করব? So do you know যে এটা হাই হইতে হলে এটাকে লো হতে হবে, right? How do I make it low? By adding or subtracting? Subtracting, right? So whenever something is coming towards you, what sign do you use? Minus. And when something is going away from you, what do you do? Plus. That's how you remember, okay? So এটা যদি low হয়, it's going away from you, which means this has to be a higher value. And how can this be a higher value? When you add both of them. Okay, so ওভাবে করে হচ্ছে না, এটা কোথায় আমি লিখে দিচ্ছি ওই জিনিসটা, এটা কোথায় ইউজ করা হয়, like what's the purpose of this, right? এটা is using speed guns. Do you know what a speed gun is? The police use for it to see how fast cars are going. Or they have this gun, they point the gun at a car, they fire what? A wave, right? The wave goes and hits your car. And if the car is coming towards you, wave ta ki dhakka de tomar dike back korbe. So that will be what frequency? Higher frequency. So they know what the original frequency is, they see what the higher frequency is. So if you place these in the equation, wouldn't you get the speed of the object, Vs, called V to speed of sound, right? Our F naught tau ora jane because the speed gun produces that, right? And F is the one that receives the sound. Mane jeta receive kora hocche. Do you understand what I'm trying to say? So I fire known frequency, let's say 1000 hertz, hits the car, comes back to me, I detect 1200 hertz. Place it in the formula, it'll tell me how fast the car is going. Okay. Some people claim that this is unfair. There's such a John speed gun detect core. Some countries they go like 80 per 0.1 gale, you get a fine, right? The argument is there's one variable here that's not actually constant. What is it? Maybe you're not going at 80, but they'll pick up you're going at 80. Yeah, sound speed vary from 320 all the way till 350, depending on what weather, pressure, temperature, অনেক factors থাকে. So on a bad weather day, you might get fined for not going actually above the speed limit. But তোমার গাড়ি show করবে on the machine that you're going above it. Okay, so yeah, that's something just general knowledge, right? So এখানে plus minus কিসের উপর depend করবে? So plus minus হচ্ছে plus when moving কি হবে towards or away, away, right? And minus when moving towards. And that is it. That's the equation. Okay, so a plus minus equation dawa ase bite, but just with plus minus e ki mean kore ota to clearly bujhe niyo. এটা একটু চেঞ্জ করে দিই কারণ উপরেরটার সাথে ম্যাচ করে দিই, f not হবে না, এটা fs হবে, এটা f not হবে। Any questions? Talk about the borough. So far, most questions from this topic appeared in MCQs, like one or two MCQs every year. Structure, I've seen maybe one question every other year. I mean, it's not very popular for structured questions. Okay, but MCQ does shit. Sometimes it's a part of a bigger question as well. Like, you know, it's a question on something else, just last day doctor. Upcoming mock. Now, upcoming mock is on 17th. That's just book one. So book one is 2/3 year syllabus. No ways, like. Done. Yeah, book one ends at pressure. So deformation, waves, electricity হচ্ছে this book. So এটা বাদে যা আছে ওগুলো হবে. Yeah, so তোমার school কি do you get a schedule on when it like goes into vacation or something? Oh, it's already. Do you know when it ends? আচ্ছা মানে mastermind শুরু হয়ে গেছে and your school as well. Any other school their vacation 22nd. Yeah, because I want to take a few classes in the morning, so I'm trying to figure out when is that suitable. Wednesday, Thursday's closed. Then Saturday, Monday as well. Sorry, Sunday, Monday. No. Oh, so your weekend has been shifted to Wednesday and Thursday. Wait. And then again close on. Acha, so 19. Acha, this coming Wednesday, is that okay with everyone? It'll be makeup class. I'll try to move ahead with the syllabus. It's going to be online only. Is 10:30 fine with you guys? 10:30, okay. Wednesday, 10:30. I'll try to take another one on 13th as well. 13th is the bond, right? Sure. I mean, yeah. I'll post in a Google Classroom after I confirm. Okay, let's move on. So tonight, there's some math that I could have given you right now, but I want to start another topic. Okay, so to Agai, there are like very small bits and pieces that we need to cover. Our main aim, just is something called stationary waves. If we are done with stationary waves, we're done with what I would say is like majority of waves. Okay, so stationary waves start করতে যাচ্ছি. And which is the most complicated part of your waves. Okay, stationary waves, and there's this thing called double slit interference experiment. These two. Okay, we have lots of pieces. We'll wrap up with this. So yeah, go to page number 38. This is an interesting chapter. It was added last year, no, 22 last year. It's very complicated. Okay, one day question we wrote that so far. Duita খুবই ঝামেলার question, so দেখে নাও. Right, so screen electromagnetic spectrum 7.4, state that all electromagnetic waves are transverse wave travel at the same speed in free space. This is O-level stuff. It is not a difficult one. So can you tell me what are common properties of electromagnetic waves? 3 properties of electromagnetic waves. Right, they all travel at 3 into 10 to the power 8 meter per second in vacuum. Number 2, they're all transverse waves. So longitudinal waves can't do what these waves can do. So yeah, transverse waves. There's one more. Yeah, they don't necessarily need any medium to travel through, but if there's a medium, they do travel through it. Okay, so yeah, these are the 3 main properties out there. So when the Mars question, they also accepted they transfer what? Energy. I mean, that's the thing they do. Recall the approximate range of wavelengths in free space of the principal region of electromagnetic spectrum from radio waves to gamma rays. Recall the wavelength of range out for visible light in human eye. So এটা দেখি তোমাদের মনে আছে নাকি? I normally teach it in all levels because I don't want to spend time on this in A levels, but তাও জিজ্ঞেস করে দেখি. Can you tell me the spectrum, the sequence? Tell me from decreasing wavelength, increase in frequency. কি হবে? আচ্ছা, tell me which one has the longest wavelength? Radio waves, right? তারপরে then start. So the first one is radio waves. তারপরে what's up to radio? Microwaves, which is not true. তাও লিখি। তারপরে কি আসে? Infrared, then visible light, then yes, UV, তারপরে X-rays, তারপরে yeah, there's one extra gap, don't worry. So gamma rays, right? So yeah, this is your spectrum. এখানে একটা part missing, ওটা কোনো জায়গায় শেখানো হয় না। ওটা হচ্ছে between radio waves and microwaves there's a gap. So তোমরা যদি wavelength check করো, ওই wavelength এ দেখবা there's a bit of a gap আছে there actually. I mean, exact values গুলো বলি তোমাদেরকে. So are you supposed to memorize each of the wavelengths? No. What are you supposed to know though? You need to know estimates. Remember estimates? We had a topic, right? Oh yeah, estimates গুলো তোমাদের মনে রাখতে হবে. So আমি appropriate estimates গুলো দিচ্ছি. Right. So can anyone tell me from radio waves to gamma rays what happens to my wavelength? Decreases because radio has the longest wavelength and gamma has the shortest wavelength. So lambda decreases, and as a consequence, what happens to your frequency? Frequency increases. Right. So the question for you is, can you tell me what is the radio wave range? মানে কিরকম হয়? Is it a millimeter? Is it a centimeter? Is it a meter? Is it a couple of meters? But what's an approximation? I'm using 1 millimeter, 1 centimeter, 1 meter, 10 meter. What's a good number here for the wavelength of a radio wave? Acha, okay, so we need to learn. Radio waves it's in the range of meters. 10 meter is an approximate number. Okay, so 10 meter ashepashe hole is fine. How big can they get? Really big. Okay, like 150 meters hoy, the ones that come from space. How small they can get? Close to a meter. Meter cross kore na. Acha mane or niche jay na. So yeah, that's a rough range for it. So ami ekhane number ta diye di. Greater than 1 meter. Tale easier hobe. What about microwaves? What do you think is the size of a microwave? 1? That's the problem. Achha, so it's a 1 meter actually. It is about 1 millimeter. So the question is, wait, 1 meter beshi radio waves are microwaves over 1 millimeter. Isn't there a big gap in between, right? Oita tomde shikano hoy na. Okay, it's called, what is it called? It's called tera waves. TERRA, tera waves. It's exclusively used for military purpose. So military satellites and communication ওরা use করে. So তার জন্য হচ্ছে এটা কোনো civilian use নাই তো, so শেখানো হয় না. Okay, so you'll find this gap here. তারপরে গুলো all math. So what is infrared? It's going to be around এটার ভ্যালুটা আমাদের exact জানতে হবে. So infrared is approximately 1000 nanometer. Visible light আমাকে বলতে পারো what's the first color in the visible light here? Infrared এর পরে red. এটা মনে রাখা খুব easy কিন্তু infrared মানে জানো তো what does it mean? It means weaker red, inferior red. ওখান থেকে infrared আসছে. So red এর থেকে একটু কম red, so the color lose করে ফেলে. What does it become? Infrared. Okay, so that's your red here, and red থেকে যেতে যেতে on the other side কি আসবে? Now violet. Okay, with your V, violet, and violet এর পরে naturally কি আসে? Ultraviolet. What does ultraviolet mean? Extraviolet. Okay, so বুঝছো inferior ওদিকে হচ্ছে ultra extra. ওটা মনে রাখতে easier. এগুলোর ভ্যালু তোমাদের এক্সাক্ট জানতে হবে. So red হচ্ছে 700 nanometer, আর violet হচ্ছে I think তোমাদের উপর সিলেবাসে কত লেখা 400, মানে ওই পেজটার মধ্যে দেখো তো 400. আচ্ছা, some books say 300, some books say 400, so we'll stick to 400. So 400 nanometer. This one is around 200 nanometer, ultraviolet. X-rays হচ্ছে তোমাদের বইতে লেখা নেই, এখানে দেখিনি. It's less than 1 nanometer. Our gamma is less than 1. Do you know what a pico is? 10 to the power minus 12. Okay. Right. So that's the range that you need to know here. Do you know the spectrum breakdown? Violet, auric acid. Yeah, indigo, blue, green, yellow, orange, red. Acha bhi janta hobe. But a color janta hobe na, but janta hobe. No, but you can guess. 7 parts, 700, 400, divide by 7. Each color changes by that amount.
the